Hey folks, Segasonicfan here, and I'm back for a part 2. Going to explain to you all the steps I did to finish off this Sangean CCRadio Plus, which is really just a crash course in an Arduino Debounce and Latch circuit install, as well as some interesting stuff I learned and a way to fix the flicker that happens on the output of an Arduino during power up, which is a super annoying issue. I'm pretty new to Arduino programming and stuff, so I'm used to hardware and other stuff that doesn't do things like that. So I'm going to go ahead and power up this radio. You'll see I've now installed the Arduino Nano in there, and I'll go ahead and turn this on. And you'll notice there's no flicker whatsoever. And now when I press the light button, bam, we got a real nice blue light there. Of course, this was green originally, and this light was always on when I had it plugged in. And now, of course, it's been modified to turn on just when I want it. So I'm pretty happy with that. But what may deter all of you is how incredibly hard that was, or let's just say intermediate difficulty, to actually do that hack. Let's go over the steps. And if you're crazy enough to be like me and try it, you're invited. You can do it. But, if you want to just learn, it's also just an interesting thing to learn about. So the first thing I do is I talk about what I did in part 1, which was installing the driver for this knockoff Arduino Nano board, which is the CH340 driver. Open the IDE, select your COM port, which is basically, it lets the program know which USB port you're using. Arduino Nano is what you select as the thing you're programming. That's the microcontroller that's on the board, and the programmer, this one I seem to have a little more success with. Now, as far as changing the code, I'm using digital 3 and digital 9. Digital 3 is the input for the button, digital 9 is the output for the LED. This part's really important, changing the code so that the button initializes as high instead of low. And that's because of what I believe is a mistake in the code, where they're expecting you to short the button to 5 volts to change states, which I think is really silly. You can upload it and test it now. I guess you could solder these things, so you can do steps 10 and 11 first. You want to add a 10K pull-up to D3, which is the button that keeps it high, and then you press it, it goes low. The other side of the button, I should point out, goes to ground. And then you add a resistor for your LEDs. 470 is a good one to start out with if you're powering blue LEDs, because those have a higher forward voltage. And I went ahead and used these blue LEDs that are diffused, kind of flat LEDs, 2.5.7 millimeters. You can use standard T1 and a thirds if you want. Pretty much any LED will work. I don't know if the diffused are helping me out or not. Hard to say. It's already going through a diffuser in the back there, and I am no expert on the complexities of physics and lighting things, but this seems to work well enough. And you go ahead and you want to test the PCB before you install it. And I've read that this PCB actually supports a 12-volt input, which is actually what this system runs off of. 12, that's around 13 if you actually measure it. And if you look over here, let's get the light going. Those 2 points here, 2 points. I'm going to go ahead and unplug this before I break something. The 2 points right here, that's your large decoupling capacitor. This is your DC voltage coming in after a bridge rectifier, and that's your decoupling capacitor. So those 2 points I wired right there, that's about 13 volts. It might be a little bit higher than 13, but as far as I understand, the Nano should handle it, and that's because it has this chip normally installed on the underside, and that's a step-down voltage regulator. Now this might get a little hot, so I have here as an optional step that you can add a heatsink. Now a heatsink can be anything attached to that little metal part there. It could be this, it could be some piece of scrap metal you have laying around, just something to let it dissipate that heat, because you are doing a significant voltage drop from about 13 to 5. It's pretty significant. And so after that, you should be doing pretty well. You'll see I just used the button ground here to hold the board down, to ground there, and the USB port here to ground here. That holds it down. I did miss a step here. You do have to separate this button. You do have to cut the trace. Let's go ahead And 19, cut trace to old on CC plus. So you do have to cut that trace to isolate the circuit, and you also have to cut the traces to isolate your LEDs. You don't want it connected anywhere in here. You're making a whole new circuit, of course. So I did all that, and I was like, okay, cool, everything's done. Well, not quite. When I power this up, there's a little flicker. Every single time I power it up, the thing was going to flicker at me. And that looks buggy and stupid and annoying. And I was like, why is it doing that? Well, welcome to the world of programming. Apparently, that issue is a known problem with Arduino stuff, and it has to do with the bootloader code. There is a bootloader code for this microcontroller, and that's basically an LED indication that the bootloader checks out. To fix that, get this, you have to recompile the bootloader and program this with a separate programmer instead of doing it over USB. So you have to bypass the bootloader. That's ridiculous. That's so much work. It's so annoying, and just explains why I get so frustrated with programming stuff. Fortunately, I came up with a solution that's far easier for you people with a soldering iron and a few parts around, and that is an N-channel FET. An N-channel FET and an RC will easily fix this problem. You have 5 volts from your, going to your Atmel microcontroller. You run that through a 1 mega ohm resistor. Keep in mind this is 1,000,000 ohms, and a 10 microfarad capacitor, kind of a chunky capacitor. And this goes to an N-channel FET, forgive my crappy NFET symbol, and that will go to the ground pin of your 2 LEDs. So what is this doing? Well, basically when your Arduino is finally powered off this 5 volts, that's my 10K pull up to the button, by the way. But when this 5 volts comes up, right, it's powered up, and then, it'll take a second of doing its flicker thing. Well, while it's doing the flicker thing, your LEDs are not actually getting power because this NFET isn't letting the ground go through it until it gets enough voltage on the gate. This is the gate right here. Well, that 5 volts is going to come in real slow because it's got to go through this 1 mega ohm resistor, and that limits the current to charge up this 10 microfarad capacitor. So it takes a couple seconds to do that. And guess what? That couple of seconds is when the flicker would be happening if the output was active. So as a result, you get the very nice, very clean, very professional looking, and not at all buggy LED backlight. The blue LED backlight, which nobody asked for. And there you go. I should turn off my light so you can actually see it. There you go. And it does a very adequate job. The debouncing circuit's quite nice. I'm totally happy with that. And we are good to go. I'm going to put this all back together. I might make one last, hey, it's all back together kind of video. But yeah, it's a nice little crash course in how to use an Arduino for something really basic. It's kind of the perfect starter project for me. And even though there's some hiccups, I am learning about, the limitations of these things as well. Also, I went ahead and removed the CH340 chip, the programming chip. Well, actually, it's a transcoder. I removed this as well as the USB port to use for future projects because this is going to be permanently in here. There's no point in wasting that. Something you can think about if you're really economical, I guess you could say. You can repurpose these LEDs here. You can take off some parts that you're not going to use because this is going to be permanently installed. I don't plan on ever coming back to this thing and reprogramming it. That's just silly. So it works for what it's supposed to do. And now I have a different color backlight. Again, I did this because my original backlight LEDs broke when I was repairing the LCD here. I do have another video talking about the LCD repair. Please feel free to check it out. I'll try to link it. I also went through and replaced all of these buttons because they are known to commonly fail, and they failed in my unit where they were kind of intermittent. That is actually due to a mechanical engineering failure, which is really unfortunate, where these buttons are, you can see they're just angling the way they come down, and they're hitting these tactile push buttons at an angle, which is real bad. They also are applying too much pressure more than likely because they have no stopper as far as the force that you put on them, and they're just too big. I mean, there's a lot of mechanical engineering failures there, which is why these break. Once they break, the only way to fix it, I get some emails from people about my other video. How do you fix these buttons? Well, sorry, folks, you got to tear down this whole thing and you got to resolder new buttons in. And it's a project. It'll take you it took me like maybe half an hour, maybe more, just because, it just takes a while. It's tedious. You can see this whole row of buttons there. These are right angle tactile push buttons. I think they're 6mm. Anyway, it's pretty standard stuff. You can get a bag of them for like $1 or $2. It's just tedious. So you got to really love this radio to put all this work into it. I mean, you got to love this radio. Fortunately, I do. I think it's an awesome radio. I love tech from this era. And now I fixed the LCD, I fixed the buttons, and now I fixed the backlight. So I'm going to put it all back together and enjoy me some tunes. Hopefully you found this useful. Here's another shot at the sheet. I do think I have to cut the trace to the LEDs as well, the 2 traces, both power and ground. What I mean by that is you have to isolate the LEDs. You have to cut these traces right here. Same on both sides. So that's what you do if you want to add blue LEDs with a push button interface that's slightly different to your Sangean CC Plus radio. I somehow doubt anyone's going to be crazy enough to do this. But there you go. Have fun hacking. Enjoy your programming things and other hacks. This is Segasonicfan signing out. Check out my website. Also, it's on the banner at the top of the screen. Bye.